Hello, everybody. As you can see, things look a little bit different this week. Oh, crap. That's what I get for doing this like this. Where is it? I forgot to update everything. So, Wednesday. So, as you can see, there's a new layout. Everything looks completely different. And hopefully that's a good thing. And now it's even updated with proper text. So, let's see here. Hello, Federico. Welcome to the stream. As you can see, I have rebuilt my system. It now has all sorts of different things. So for anybody interested, actually, before I go into that, this is the first time I've streamed now in about 2 weeks. Previously, for anybody who missed it, we were looking at numpy. Specifically, we were going after the trying to fuzz crashes with the generative fuzzer to find, hopefully, exploitable bugs in the numpy module itself. So we spent, this is our 4th week doing this, and the plan today is to go through and actually triage some of those crashes. So, and I've actually pulled them down here now. So as you can see, we have all these crashes. In particular, crap, I lost my timestamps when I copied it. In particular, here are all of the different PCs that we have now. I went through yesterday, I think, and I sorted everything out so that we have a much easier way to look at these crashes rather than having just... So if you remember last week when we were going through them, I believe it's EC2? Like, this is what we were going through and trying to find things and moving them around and trying to understand them. And I just wrote a little bit of Python, so now we have this, and that's so much cleaner to look at. So, like I was saying, today's stream is going to be going through and trying to triage some of them. We already triaged a few of them. In particular, we took a look at a few of these up here. They're mostly related to the int as buff function. But none of them seemed exploitable. They would be able to let us read arbitrary memory, but given the fact that we already were able to write Python for it, I'm not sure it made a lot of sense to do anything useful with it. One thing that we missed last week when we were taking a look at them was this one right here. So I had to take a look at it when I noticed that for whatever reason, we have a crash at PC of 31. And at this point, I don't think this one is exploitable, but we're definitely going to take a look at it. It's probably going to be the first one we take a look at, because whenever you see PC that is clearly not in a code segment, like PC of 31 is very clearly not, like there's no way we can have code at OX31. I think all modern Linuxes completely disallow you from being able to do that. That you can't even map in that page if you wanted to. So that is clearly, we had a jump there. We're definitely going to take a look at that one. And then after that, we have all of these crashes to take a look at too. So all of these are in libc, I believe. We'll take a look at it a little bit later. But these, so the ones we looked at last week had to do with, were these in here. And these were the ones that were crashing in the Python runtime. So for whatever reason, we had some corruption that someplace in the Python binary, we got a crash. And unfortunately, none of those seemed particularly interesting. There was the int as buff thing, and then there was something in dictionaries that wasn't getting initialized right, and it was a null deref. So neither of those looked particularly interesting. These are hopefully going to be more interesting. They're either in the numpy runtime itself, or in libc or something like that, and we'll take a look at it in a little bit and see exactly where we are. So that's those two things. That was one thing, not two things. Sorry. As you can see, I've still got a little bit of congestion here. Hopefully my voice holds out for a while so we can get a nice stream going, because I spent all weekend trying to get things put together so things look better. Like I've got this whole nice layout now that we have information on the screen. We have the chat over here so that if you come after the fact, so I know a lot of the people who watch these streams don't actually watch them live. The majority of people watch them after the fact, after they've been recorded. The problem with that is that for some of the streams that I enjoy the most, I've had a lot of interaction with people in the chat, and losing that means that whoever is watching this afterwards, if I don't remember to read the question out loud and repeat it, they completely miss what the question is, and it sounds like I'm just rambling. But now it's on the screen, and now that it's on the screen, we have it. It's great. Everything is awesome. Other than that, down in the bottom, if you have not already, I try and talk about, on Twitter, I try and talk about the stream and things that I'm going to do. On Mastodon, which is that poning.social, I've been talking about more general things, like things that I'd like to do in the future as opposed to more immediate things. The longer form that they allow for there makes it a better place to do that, I think. So I think it's about all that's important right now. What I started to talk about when we first started the stream is that I have completely rebuilt the system that I'm using for this. Previously, I've been using the same machine that I actually play CTFs on. I rebuilt my desktop here, and we now have a system that is a little bit different. One thing that I think is super interesting is that what you're seeing here is actually just Windows. So I'm actually taking advantage of the Windows, the WSL. It's the Ubuntu or Bash on Ubuntu on Windows. So it's the new subsystem in Windows 10 so that you're able to run Ubuntu with Bash on Windows, and it runs natively. Now, I'm not actually doing things on that. I'm still SSHing into a real Ubuntu machine because I didn't think I was going to be able to get very far trying to do all of this in that runtime. It's not quite there yet, but it's getting there. But having a native Bash, so I'm able to do all of my SSHing completely natively in Windows now, is awesome. I like it a lot. It seems great. At least so far, I've liked it a lot. The hardest problem was fixing all my colorization stuff. If you try and run into it, I don't have the link ready right now, but if anybody tries this and runs into the same color problems that I did, remind me on Twitter. I'll post the link that I had. There were some registry edits to change all the colors because the default color for blue was completely unreadable on my screen. It completely merged with the black there, and I couldn't get anything out of it. So yeah, like I said, I spent a lot of time over the weekend getting stuff set up and recovering from being sick. So it's really exciting to actually be able to get back in here and start looking at things. So with that said, I think it's about time to get started here. No, that's not what I want at all. So, projects, Python. Let's take some notes. So, first off, we have done an introduction, and we need to take a look at some of these crashes. And I think, of course, actually, before we do that, let's talk about, just to run through real quick, the mover. Why are you... What have I done? What have I done? My Vim is now deciding that it wants... If I ever put insert, it's going to move that to the top line. Well, we'll deal with that for... We are crash triaging. Let's just give it a try here. So, before we do any of that, So basically what we did here is, if you remember, we have this gdb.txt file, delete that. And this is just, it's a log that we wrote out. So for every one of our crashes that we had in our fuzzer, we took it, we run it in GDB, and if it crashes, we log it out and we get a result. So we get, so a single, oh, of course that's not gonna let me do that. So this right here is what a single input looks like when we did our simple triaging script. Oh, let's highlight this one because one of the features of the new layout is that I lose a little bit of text up there in the top. So anyway, we would get a PC for one of our elements. This is where the crash happened. This isn't that PyDict get item that I was talking about before. It's a null deref. We looked at it 2 weeks ago. Doesn't seem that interesting. And then we also printed out what the arguments were so that we knew which file caused the crash. And then if we go through here, there's 48,000 lines of these. So going through it manually is completely unfeasible. But we have this that I threw together real quick, which is just stupidly simple, right? We're just going to go through here. We're going to open that file. We want to create a dictionary of crashes. And we don't actually need this dictionary. For what we're actually doing here, we're just going through. If this is the first time we've seen PC, we're going to come in here. So we actually just parse this out, right? So we parse out the PC, and because we know it's going to start with OX, is the only place in that text that we would have the an OX there is when we're printing out PC. And then we know that the file name is going to start with a single quote,
okay.
And it will end.
I'll be here when you need me.
Okay. Huh. It will start with a single quote, and it will end with .py. So I'm not sure what exactly just caused that. Apparently, something that I was saying triggered the Alexa in the corner there, and apparently, if I need anything, she's there.
What can I add for you?
No! Nothing.
No added to your shopping list.
Alexa, off. Okay then, so, where were we? That completely derailed me there. Sorry about that. Right, so we go through here, and we parse out the name, we parse out the PC, and we create a dictionary. The dictionary was there so that I could look at it manually and change things a little bit. We don't actually use it for what we care about, which is we create a directory if this is the first time we've seen PC, and then we're going to copy whatever that file is into that directory. So we get all these nice directories just like this over here on the left. That's all it is. Pretty simple, just runs through that log, because that's what we really want, right? We want to be able to go through things as easily and simply as possible. Because while we have, what is this, LSWC, we've got 50 unique PCs, which, it's a lot, but it's not so many that we can't go through them manually. However, we have 75, almost 7,600 unique crashes. That's way too many to go through manually, and there's just no way we can do that. But by going through this way, sorting them out, getting a little bit of logic in there, we get it down to a number that's manageable. Like, this is probably going to take, 2 or 3 streams more. We've already done one. We got through 1, 2, 3, 4, 5, 6, 7 of them last time, which isn't many, but we also wrote all the triaging scripts. We messed with that. So hopefully, this time we're able to get through maybe a dozen of these. Another couple streams, we'll be able to get through all of them. That's the hope, at least. So, I think it's caught up with about everything that I've done in the short time period here that it's been since the last time I was able to stream. Let me see if there's anything else that I'm forgetting. I think it's everything. There is one more thing, which is as part of the move to the other system, you may notice that the sound quality is a little bit different. It might be a little bit difficult to hear because I'm still a little congested and my voice sounds a little bit off, but you may have noticed that the sound quality of Alexa was amazing when you heard her talking. Basically, I moved around how everything's doing. I have a proper mount for the mic now. Hopefully the sound quality is better. I know it's been something that's come up a few different times on the stream that the way that I was recording sound isn't great. Specifically, it was mounted. There's a huge issue when you're streaming, right? That if your microphone is attached to the desk that you're using to type on, you hear all of that. You also hear every creak and things like that, and it's kind of annoying. Now, the upside here is that I now have everything mounted properly so that you don't hear all that creaking. The downside is that I'm on a desktop now with a real keyboard, and it puts out a lot more sound. So it's kind of a toss-up. Hopefully it works out better, but we'll see. So I think if there's anything else we should discuss before we jump into this, and I don't think there is. Yeah, let's take a look at these. So let's start out with the first one here, and I mentioned this real quick because this right here is super exciting, right? We have this PC of 31, and what that says to me is that no module. Sorry, I apparently forgot to numpy Python-numpy. Oh. Part of the downside of a new system is that clearly I forget to install stuff on here. I got everything copied over, I forgot to install numpy. Yeah. So while we're waiting for this to run through real quick, if you're curious, the keyboard I'm typing on here is a Poker 3. It was one of the new keyboards that I picked up. I also have a old Corsair with cherry blues. The Poker has cherry blacks in it. I basically got it as a travel keyboard because I at least used to travel around quite a bit for work. So having a nice small keyboard like this was exactly what I wanted. Hello! So, where were we? We were going to run this thing and see where it got to. What is this? Well, this is interesting. It would appear that this does not reproduce on here. So I did verify that this actually reproduced on the machine we were using. However, let's check this out real quick. Sorry, here we have apparently some technical difficulties with reproducing one of these crashes. Oh. I'm booting up the other machine that I had been using for all the streaming, so I can take a look at it real quick and see why has it betrayed me. What is going on here? My guess is that we're using a slightly different version of numpy here. So this new VM is a Ubuntu 1704 VM that we're using, whereas the old ones were 1604, I think. Well, so I don't think Python 3... So using Python 3 is probably exactly the opposite of what we want to do. Because all of our crashes previously were with... were definitely with Python 2.7. Come on. So, unfortunately, you can't actually see it because I don't have the other machine set up to stream anymore, which is unfortunate. But, come on. Run. Oh, great. Mm. And this is why we reset this other machine. This is why we stopped using this one. Yep, there we go. Python crash. Import numpy, numpy.version.version. So the version we were fuzzing on was 1.11.0, whereas the version on 1704 is 1.12.1, which means that whatever crash we had, it looks like they fixed it, or for some other reason, actually changed things, which is actually really interesting, right? So, among other things, so differences here, and this is the downside of switching machines in the middle of one of our series here, is that this new VM is using Python 2.7.13. The old one was using 2.7.12. They also compiled with different versions of GCC, which is a little interesting. The 1604 Python was apparently GCC 5.4.0 as opposed to the 6.3.0 that this new one is using. But the difference in NumPy version means that whatever it was that was causing this has gone away now. So it might be a good idea then. Trying to think of what the best approach here is. If this is something that was fixed, it doesn't make much sense for us to go back and hammer against it, try and poke at a crash that got fixed and patched out. But at the same time, it'd be kind of fun to see. I think, at least for now, we're going to skip over this one. While it's an interesting looking crash, it's also an offset from 0. Which means one of two things. That either we had a uninitialized area that was used as a pointer, or that we were supposed to initialize something and never did. In either case, there's a decent chance it was not exploitable to begin with. That said, it's definitely something that I'd be interested in going back to and looking at later, but we'll see. So, why are you doing that? Okay, I'm gonna go look this up real quick. Vin. Okay, well. I guess we're just gonna live with this. That's unfortunate. Or sorry, we're going to be rebuilding these real quick. Yeah, okay. What? Oh. Oh. Sorry, everybody. We're gonna get here in a second. There we go. So for anybody who's curious what was going on there, so the issue... Oh, and I still haven't done this real quick. Resize. Resize to 80. Right, so what was happening there was, because I'm using screen here, screen thought we had a full height to use for Vim. So when we inserted it, was moving things around for us, because Vim thought that we had just this we had all of these lines, when in reality we only had these lines. So it was trying to be helpful, but wrong. So we're fixed now. Where were we? OX31, not repro... What am I doing? Let's do this the right way. So, projects, crashes, Python. Yes. LS, I thought there was a good way to do this. Q. Oh, crap. Well, I guess that did not do what I wanted it to do at all, did it? Oh, that's unfortunate. There we go. So what we're doing here is we're using Vim macros. That didn't do what I wanted. This looks right, right? Yeah, that looks right. Let's just clean this up real quick. Okay. Sorry about this, everybody. This is just a little bit easier for me to look at, which is why we're doing this. There we go. So, this one, no repro. This one is last stream. I don't remember what each of these is, unfortunately. I do remember that we decided that none of these were going to be exploitable, at least not in any sort of meaningful way. So, oops. Let's go on to the next one. CD into that. Oh, that's not what I wanted. CD into 7F 6891. This thing. So this is another one that only has one test case. Well, this is going to be pretty unfortunate if it turns out a number of the crashes that we had were actually things that were changed or fixed in later versions, given that this appears to be a non-crashing input. Right? So looking at this, we did not get a seg fault, which indicates to me that we probably might have messed something up. OX7FFF. Let's see, 7, oh, 68 B8FD3. There we go. Let's try a few more of these before we decide everything is awful and we... 7F... This is really unfortunate, given that we're now a couple of different crashes in, and it looks like many, if not all of them, have been fixed in the later versions of Python that we did not bother to look at because we just used whatever was on my system. Is that it? That's promising. We're still running. There we go. So this one did not repro, no repro. Well, it's good to see that we are not complete failures, that at least some of these are real bugs that are doing real things. So, oh, crap. GDB init. Disassembly flavor intel. So we are trying to read from RDX, and RDX is -1. That's, interesting. Okay, I'll buy that this is a thing that should not be happening, and that is exactly what we were hoping to find here. 7F, 6918. So, what does this thing look like? So we're calling np.asArray checkFinit. We are calling int as buffer. Ugh. Oops. Yep, this is unfortunately, same thing we've been seeing. One thing that's interesting here, and that is worth noting, so last week we discovered, or 2 weeks ago, when we did the last set of streams, we found out about this int as buffer function. So that int as buffer function is kind of a complete mess, right? It's a numpy function which takes a Python integer and then casts it to a pointer and reads bytes out of it. Which, sounds completely crazy. Why on earth would you do that in a math library? Like, I can understand you're, writing C types, like, okay, this being a function in C types makes a lot of sense. It being a function in numpy, not so much. And one thing that we found last time was that we could get the function to crash, even though there's code to make it not crash. I think one of these optional arguments lets us get away with it, but that's what that is. Let's int as buff, or as buffer. That's disappointing to say the least, but we can go on.
Sorry, I'm not sure.
Just a second here. This is going away. Apparently, with my congestion, I sound like I'm saying Alexa way more than I actually am. Sorry about the delay here. I am logging in now and shutting her off. Come on. How do I... Alexa? Oh, you're supposed to be off. How do I do that on here? Like, I just turned it off. Alexa? Turn yourself off. No. Heck. Okay. Constantly, yes. Okay. So then, sorry about that, a little bit of a distraction there. Apparently, my congestion makes me sound like I'm saying Alexa a lot. What do you know? Anyway, where were we? If we go back into what we were doing, we want this one. Ooh, another one that reproduces. Before we go too far, let's verify that it's not the same int as buff stuff that we've been seeing for a while here. And it is not. That's exciting. So, this means that we actually got something a little bit different this time. It's finally a new crash. Ooh, that's exciting. That's actually really exciting. So, if you see here, we're actually crashing in mallet consolidate. And given that we're crashing in mallet consolidate, that's telling me that we probably got, somehow, an out-of-bounds write in a heap allocation, right? So, unfortunately, this is going to break a little bit here. Sorry, everybody. So, we want to take this. I want to add a window paint. Oh, and you should go down here. Okay. So like I said, unfortunately, this is going to be a little bit of a not great to do it. JFoot on... Yeah, so there's Vax mentioned in the chat here that there's a number of plugins for trying to determine if a given crash is exploitable. And if we were... so I'm not sure about the one that they're mentioning in particular there. I've used a number of them in the past. And one of the things that I don't like about them is that they take away what I'm doing. So... I can draw in here now, can't I? So when I'm thinking about doing fuzzing or any sort of stuff, basically what I want to do is I want to get... let's not use this. We're going to use... Did they get rid of it? Okay, I guess I'm using... There we go. Right, so if I'm doing fuzzing, right, what I want to do is I want to get a handful of things, because if I have one thing, I can very easily take a look at that one thing, and I can say, oh, here's what that is. If I have, 200 things, I've got, let's make this look a little bit reasonable. So in the case where we have, hundreds and hundreds of crashes, where, our fuzzer was amazing, we got all these crashes that are just all over the place. Now that's a problem for me. I can't look at 200 crashes. Well, I can, but it's going to take me probably hours to look at those manually. More than hours. That's going to take me probably days to look through manually. I'm not that amazing that I can look through 200 unique crashes in 2 hours. That's a problem for me, right? If I'm trying to look at all of these manually, I can't do it, and that's where those automated triaging scripts really shine. When I have a ton of different crashes, I can usually take something like exploitable or equivalent things, and just one off, I run it. Usually it's something like I would come in here and I do bang exploitable. And it'll tell me, oh, here is well, it wouldn't be bang. That's how you do it in the WinDebug versions of it. But, I would get a new command that I could say exploitable. And it would say, oh, you crashed because of this reason. Here's why we think you're exploitable. Or don't think you're exploitable. And those are great if I have a ton of crashes. Where we are right now is we're right in this middle ground where, personally, I would want to have about 20 unique things to look at. Because at the 20 mark, if I spend, half an hour on each of these, it takes me about a day to go through all of them. And that's pretty reasonable. If I, I built, if I talk about, here's the exploitable thing that I was talking about. Anyway, having both of these to switch back and forth with is a little bit confusing still. But if I take, one day, where's my mouse? So if I take one day, so let's say I wanted to spend, a week on trying to land, I want to find a vulnerability in, numpy. Let's say a week-ish is reasonable because it's a relatively easy target. Now, I want to spend a little bit of time writing a fuzzer. I want to spend a little bit of time triaging the crash. And then for the most part, I want to spend most of the time that I have, though, going through and actually landing it, because I probably want to spend about half my time trying to land whatever vulnerability we decide on. The reason for that is because for a lot of modern systems, the hard part isn't finding the bug. So it's definitely difficult. I'm not, shitting on anybody here. Finding bugs is not always the hard part. A lot of the time, so if you talk about something like, a Chrome exploit, or, if I wanted to have a remote root on iOS, kind of the holy grail of exploitation right now is I have, you go to a web page in Safari on your iPhone, and I get a full remote compromise of your system. That is top tier. That is the best kind of exploit you could possibly have for terms of being valuable, being dangerous, things like that. Now, finding that Safari bug, it's difficult. It's definitely difficult, and it's something that, lots of people spend lots of time doing. But for a system like that, it's not enough to have just one Safari bug. I need a Safari bug, I need a sandbox escape, I need some sort of a kernel priv-esque, I probably need, I probably actually need two different bugs. One is, a write of some sort, write, and a second bug which lets me read arbitrary memory. Ugh, that looks awful. I need to work on my paint writing, apparently. And, each of these might be different bugs. I need to chain them all together. Actually doing all the exploitation work here is, on modern systems, harder than just finding a bug. Talking about the general workflow that I want to be able to find some set of things in this first chunk of time. I want to find enough things that I can manually look at them. And then, so if this first one is, I write a thing to find things. I have some idea of what I want to find. In this case, for the Python stuff, or for numpy in particular, we said, I want to find numpy crashes that I can create through a generative fuzzer. We wrote a generative fuzzer, we set up a test harness, we ran it, which put us into the second block. The second block was, okay, what did we get? And at that point, well, so the second block is I let it run, right? For these streams, I left, I did other things, I did my day job, I slept, came back, we had crashes. And then in this third box, this is the triaging we're doing right here. And ideally, I want this part to be something that I can do reasonably in about a day. Because if I'm wrong, if I don't have any crashes, if I don't have any useful crashes, then I need to take the information I learned here and come back over here and build something else and start over. And having this like relatively short turnaround, a day to build what we're going to test, a day to let it run, and then a day to go through the results. That's relatively quick turnaround. It means that if I'm doing this full time, I can easily get 2 of these cycles in a week if I need to, and then drop into actual exploitation. So like Vax is saying in the chat, the exploitable things, they're amazing for trying to determine if I have a ton of crashes, what do I look at? Where we are right now, we're in a situation where that's not that much of an issue. We've got about 50 of them, which is enough that we can probably do them in 2 or 3 streams. It's a little bit on the high side that I'd kind of like to have something automated, but at least at this point we don't need it. Which is a really long way of saying we're going to do these manually. So, back to where we were. Look at that. I even remember to switch screens. It's so amazing. Let's pop. Yes. We have a mallet consolidate here, which says to me that we probably ended up getting it out of bounds right. And the reason for that is, actually, we're going to go back over to Paint, and we're going to actually try and explain why. So let's get rid of all... Oh. Select. No, I don't want to crop that. I want to... Oh, here. Paint, how do I use you? There we go. Wait, what are you... There we go. Need to learn how to use my tools, apparently. Especially when I'm choosing bad tools, like MS Paint. But... Where were we? Let's zoom back in here. So, when we talked, it was during the PDF crack streams, we talked about what exactly does heap exploitation look like when we're using glibc, the glibc dlmalloc implementation. The way that looks like is we have a little bit of metadata, then we have all the data that we have. So if I call malloc of, 50 bytes, this mouse is not doing as well of doing this as I'd like. We have this little bit of metadata here, and then at the end of this, we're going to have another block, which has its own metadata, and some amount of space for its own data here. And basically, like, this is the way that things work, right? So if we have an out-of-bounds write in this 50, we might smash this metadata. And when we smash this metadata, when we free that block, it's going to cause problems sometimes. My guess here is that when I see something that is in... Sorry. When I see something that's in malloc consolidate like this, what that says to me is that we tried to consolidate one of these things. And one of the most important parts in this metadata is the length of the block. So there's a couple different pieces of metadata in here. There's a few different things like what type of an allocation is it, which arena is it in, things like that. But the part that's most important is the size of this block and potentially the size of the previous block. It has to do with how things are free, if something is free or not, and things like that. So if we're ending up with a consolidate crash, it means that Yeah, PowerPoint's probably a better idea than Paint. I think for Wednesday, I'm going to find a little bit better of an option. I think my biggest issue right now is actually the mouse isn't giving me the precision I'd like. We're going to fix that. I'm not quite sure how, but we're going to fix that for next week. Or Wednesday. So going back to this, right? So when we're in this consolidate, it says to me that we overwrote that metadata somehow because we are trying to... That's interesting. So we didn't actually get quite the crash that I expected. Think about this for a second. What I was expecting to see here was that we were crashing in part of the consolidate that was calculating the... No, we are. How did we end up here? Okay. Hex that thing. Thanks. 264. Well, that doesn't look helpful either. So, it helps if I got the number right. So this is interesting. We're getting a crash here in an area that I don't really expect to see a crash. Because that number doesn't jump out to me as being something that is inherently wrong. And if we take a look at this, what did we do here? So this is the file, right? 7 2 show args, print args, yeah. 7f2 AC, yeah, this is the same file. So this is the right file. We initialized a NP column stack. We then called set field on it, and the arguments we passed into set field were a datetime object and 2 to the 64 minus 1 as a float. What on earth happened here? So we called set field. So first off, we called column stack. Okay. Import numpy as np. Yeah, so we have the backtrace up here at the top of the screen, where we're actually in finalize, which is a little odd to me. So the finalize is getting called after everything is run. So everything ran fine. It didn't crash when that happened. And then when Python was cleaning everything up is when we actually crashed. So something when it was freeing everything out of the entire heap that had been created. So, sorry. So C is equal to NP column stack. It takes an argument. I'm going to pass np.fast copy and transpose a times 256. Okay, makes sense. That's a thing. So I'm not quite sure what that's doing. That's doing a thing. And then we do C set field. We want to call it with np.date. What exactly is this? So np.date times 64. Okay. C.set field np.date times 64. And then np.cfloat worked fine, apparently. So you'll notice that I, oops. Oh. For numpy as np. I called it slightly differently this time, that time when it didn't crash. I was hoping that if we called it with a c float of something that wasn't -1, that something special would happen. Looks like that's not the case. np.datetime64 np.c float 2 to the 64 minus 1. What? Why do you not like that? This is interesting to me. I'm not sure why this is crashing now. So, this is exciting. We're gonna try and minimize this a little bit. cd project crashes Python, and this is OX. Oh no, which one is this? FF786F. This thing. Yes, we still crash. Okay. The value we pass in doesn't matter. So basically what we're doing here is we're going through and we're just saying, okay, what if it's not a float? So it needs to be a C float, whatever a C float is. But the value of the C float doesn't matter. Okay? Oh. Well, that's definitely interesting. This is interesting for a number of reasons, right? This definitely seems wrong. So, we need to take the next step here, which is... which screen do I want this on? NumPy. We're going to build NumPy from source, which is unfortunate that we're going to have to do this. This is going to take a little bit of... tomfoolery, is that the right word that I want to use here? Projects, we want to git clone this. What I'm hoping for is that this is relatively straightforward. I haven't actually built NumPy before, so this might not be quite as straightforward as I'm hoping it is, but at least my hope here is that I'm able to just run like configure make and then pass in some different arguments. So let's do that first. numpy is the fundamental package. How do I build it? Like, how do I build all this stuff? Because clearly it's not built when I just pulled it from source. Oh. See building for instructions. Building from source on Linux. So I want to do Python setup build. Python or pip. I have pip. Yes, go ahead. Right, so I don't actually want to run the install there. If I actually run install, it's going to build it, it's going to put it on the system, and that's not what I want. What I want to do is I want to figure out how this build works, because what I want to end up doing is hopefully I'm able to build numpy with ASAN, because that's going to tell me exactly when we got our out of bounds right. Which again, is kind of an assumption here. It's entirely possible that I don't actually have an out of bounds right. There's a number of different things that can cause this crash. At this point, we don't actually know what it is. But before building, I will also need to install the following packages. I have GCC, I might need Fortran. I will need Python dev, like Cassiano said. Okay, that's the wrong window. So apt-get install Python dev. Probably don't have Clang on here either, do I? Oh, I do have that. Oh, that's going to take a little while. Right, because ideally what we're going to do here is we're going to build a ASAN version of this. We're going to be able to run this through, and it will tell us exactly when we got that out of bounds right. Because that's one of the difficulties of doing heap exploitation, is if I am fuzzing and I come across, a stack buffer overflow, I'm going to get a crash very shortly after the place I had my overflow. Like, I'm probably in the same function still. Whereas if I have a heap overflow, which is what this appears to be, or some sort of heap out of bounds right, I don't get the same thing. The crash that I get could be any number of things, right? In this case, I'm not actually crashed. Well, I don't know about the case that we're looking at over here on the left, but the version that we fuzzed out, the crash is actually way at the end when Python is trying to shut down and clean everything up. It's not at all when we had the right, because as far as the heap is concerned, it's not a big deal. There's no metadata that we're not going to crash until that metadata gets used. The metadata doesn't get used until the block is freed, so it doesn't matter. Yeah, that's something I'm going to try and decide when we get this built. Hopefully it doesn't take too long to get everything built. So Cassiano mentions here that we're going to have to mess around with like how to load this. It's a problem that's going to come up, and I'm not entirely sure which way we're going to solve it. What I'm hoping for, though, is that it's going to be pretty straightforward. We'll see. One thing that I can do is I can specify a path and use that, and that might be the way that we do this. But where are we? Python setup.py build. Running Scythonized failed. Hopefully this works. Bam. Come on. Does that give me everything I need? Oh, it looks good. That's a lot of warnings. No, those are compile options. Okay. So that worked out reasonably well. But so numpy ASAN. So not a good sign that I don't see anything on Google about building numpy with ASAN, which is unfortunate to say the least. So this is what setup is doing. That's a whole bunch of .h files. Where does it? This is frequently one of the more frustrating parts of doing some of this vuln research. Yeah, I'm hoping it's as easy as exporting C flags, but I don't actually see where that's happening. Miss 220. That's not what I was hoping for. So the CC compiler will use CXX and CC. Okay. Yeah, so it looks like it does. So this might be pretty simple to do. I want to let this finish building though, and we can see where we are. So I want, how do I actually do that properly? So I'm going to set C. So hopefully I can do C is equal to clang. CXX is clang plus plus. C flags is equal to f sanitize is equal to address. Hopefully this just works. Like, hopefully I'm able to do Python setup and it will just work. Yeah, I think what I'm going to try first is specifying a path for it, because I can do a specific path. So I think I can give a full path, and oh, I can't do it that easily, can I? I'll play with it and see. But using virtual end will definitely work if it comes to that. It's just not something that I know how to do off the top of my head, and I'll have to. I mean, I can probably. So virtual end with the thing, I want to source it, and then install inside of it. That probably just works. Come on. That looks like it worked, right? That looks like it definitely works. Yeah. So that worked fine. Huh. That did not work fine. Clean? Really? That looks like it's working. That's awesome. Okay, so I want to do I want to do. I probably don't have virtual env installed, do I? Nope. Virtual env. Okay. Virtual. cd test source bin. Okay. Python setup build. Hopefully this works. Actually, so it would appear that we're building with Clang, but it would appear that we are not using the compile options. It's unfortunate. Yeah, humming the final countdown is probably a bad habit of mine. I'm sure at some points, like the YouTube, what's it called? Their music identification stuff is going to go, aha, we finally caught somebody. Ha 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 ha. But what do we say? We say not today for that one. projects, numpy, C flags. It says we're using C flags. So maybe I just can't read. It is actually using the fsanitize stuff that I told it to. Oh, I need to use base C flags. That's dumb. Dash F. Dash F. Sorry, F sanitize. Equal to I want to do that again. Oh, crap. So what we just did there was we actually deleted our virtual end. Thanks. Yeah, we no, I don't have it anymore. Yeah. So doing the git clone just killed my activate. Okay, we're back here. And I'm going to export cc is equal to clang. Export cxx is clang plus plus. And export base C flags. C flags is equal to dash F. Sanitize is equal to address. And just for completeness, we're also going to do just C flags. Called Spanish flea. Okay, I'm going to get this running. Okay, that's running. Spanish flea. That is quite a good choice. I like that a lot. Cannot link. What? What is all this? So it looks like we actually used both of them. That's probably not what we want then. Base C flags. C flags. File options. Okay. Undefined reference to ASAN init. I thought I passed it the right. should work. Why is that not working? Yeah. So. Oh, do we also... compiled it? How do I pass that into the link? So because they're doing it in 2 passes, I need to pass it in also there. Okay. Right, so I have a config test.c. We call clang with that. So the problem I think is right here. We're calling clang with the .o that we create, and we're not actually linking it properly. We need to pass, when we call this, we also need to pass a flag. But how we do that, I'm not quite sure. Let's see what all this information it's telling me is. Don't care about most of this stuff. Definitely don't care about the SVN stuff. So I don't think the problem is LD, right? So the problem is we need to pass it in to the linker, and will LD do that? Like the easiest thing is if we have, like ideally there's a C flags that gets passed when it calls the linker, but I'm not even sure where to look for that. Let's try this to start with. Ah, no. I... Okay. I will trust what Cassiano is saying, and hopefully everything doesn't blow up in my face. LD flags is equal to -f sanitize. I'm bad at this whole computer thing, aren't I? Like this should work, right? I feel like, I feel like this should just work. I really wish they weren't removing it so I could test this. That'd be nice. The address sanitizer runtime library should be linked to the final executable, so make sure to use clang for the final link step. When linking... Oops. Distutils, C compiler, 456. Like, all I want to do is when they call it the second time, again, assuming that this is actually true, that they're actually calling this, so at least, so this is the example from, oops, I highlight it, I copy it, I paste it. So this is what they describe in the Clang documentation, is that I should be able to do, minus all the errors because I'm just copying and pasting stuff. I should be able to do a clang-c with fsanitize address on some random file that'll generate a .o. So vim test.c and includes standard io.h, void main, printf YOLO, close that. So I should be able to do clang dash f sanitize address dash c test.c. And I should then be able to do clang dash f sanitize address test.o. See, that works fine. And I have an a.out. And that works fine. But if I do that, I get the error that I'm getting. So basically, it's when they're doing their linking that's the problem. Oh no. Oh no. This feels so dirty, but it might work. Oh, I feel so bad that that worked. That makes me feel so awful. So if you didn't catch what I just did there, the problem is that they're using Clang as the linker, like they should be, but they're not, like, I don't have a good way to pass in the flags to it when they do the linking with it. Okay. So my solution here was I changed CC from clang to clang.fsanitize so that when they build this string, it just works. Yeah, I don't know why LD flags didn't work. Like, it looks like they're not using it at all. Who knows? Yep, there's something to be said for if it works and it's gross, it still worked. What's the... There's some relatively famous quote about that, but let's hear it for being able to build things, I guess. This has been an adventure. It's not exactly the adventure that I was kind of expecting to have this evening. But one of the downsides to building a lot of these tools, or one of the downsides to doing vuln research on some of these tools, is that it can be hard to build them sometimes. Like, there's these massive open source projects that everybody thinks of as being, these relatively simple things to get working. But the actual, like, black voodoo magic that goes into building them is sometimes a huge pain in the ass to get to do anything at all other than what the developers do when they build it. Like, the developers who are building this, they don't apparently care at all about trying to do ASAN builds. Like, I'm a little surprised that there were basically zero useful results on building numpy with ASAN. Instead, the only results I found with a brief Google were things about there's apparently an ASAN thing inside of numpy that's completely different. It seems kind of silly to me that you would build a C project and not at least run it through some of these basic static analysis tools, like run it with Clang and see what happens. Because if Clang yells at you about everything, it probably means that you should take a look at that and probably fix some of that shit. The downside there is that nobody really wants to fix all that stuff. So when you're making an open source project and, well, that's taking longer than I would hope it would. But when you're making, like, when you're developing on an open source project, then you don't really want to, like, everybody wants to write cool new features and add new cool stuff to it, and the people doing the, like, fixing bugs, like, nobody wants to go through and fix this right here. There's apparently an uninitialized use of need outer iterator. I heavily suspect that literally nobody wants to go through and fix this, even though this might be some terrible, like, this is clearly an uninitialized variable, and just running through the compiler told us this. Nobody wants to fix that, though. They don't, like, that's not a sexy thing to go fix all this stuff. So, a lot of the time, they don't ever fix it. So, the downside is when somebody goes and they, I want to build this with ASAN so I can do some testing. Nobody's ever tried it before, so who knows if it's going to work, right? Yes, Kitty? She apparently, since Alexa stopped talking to us, the cat decided she would talk to us instead. So I guess while we're waiting, Cassiano was mentioning in the chat about trying to build a whole bunch of stuff on libc5. I guess you've been doing some of the... You've been a developer for a long time? Definitely, I'm definitely glad I don't have to deal with all of the ridiculousness that was, trying to build dependencies before we had halfway decent package managers. Like, there was a day and age when what we did today, just getting a build environment for numpy, could have taken hours, because I need setup tools, I needed virtual env, I needed Python, I needed, I needed Clang. Like, if I was building Clang from source, I think the last time I did that, it took a couple hours to get working properly. Getting Clang to build is definitely it's a challenge. It's definitely a challenge. Oh man, you've been a sysadmin for more than 20 years. That is definitely quite a bit of experience. Hopefully that's something you enjoy. uh, Come on. I always hate it when I'm building something like this and it hangs, because there's a part of me that's going, oh, oh, there we go. Like, I'm never quite sure why it's hanging, if it's because, you know, my terminal just hasn't refreshed or what, but it looks like it worked. So, Python setup py install. Please don't break everything on me. I really would like this to just work. Oh. Import numpy. Whoa! No. Well, we're getting closer, aren't we? So apparently our build failed in multilib, and it just didn't bother to actually complain about it. Right? Man, it's 1:30 in the morning there? I'm very grateful that you find this amusing enough to watch me try and build things at 1 in the morning. Okay, so what is breaking here? We are importing the multi-array numpy extension failed. Most likely you're trying to import a failed build of numpy. They want me to kill everything and start over. I don't want to kill everything and start over. The good news is that the virtual env stuff totally worked properly. The downside is that we are not getting the stuff that we wanted. Why did we not get this symbol? Oops. I want that a little bit over. Oh good. There are no results for this on Google. That's always the best type of error, when Google says, I've got no idea what that is. Check out last line. So, the build, as far as I can... Ah, crap. We don't have enough scroll back for it. Python setup build. Like that? Looks like it worked. / multi-array. Okay. -xdf. We're gonna do this again. We just killed our virtual env again. Crap. Okay. You know what? We're gonna do it up here, so that I stop just killing it. Source bin activate. We did this. Okay. We killed that. So export cc is equal to clang-f sanitize address. CXX is clang ++-f sanitize address. I think this should just work. Okay. The only thing that I had to study was the... Oh, man. I'm actually really interested. So the... Especially recently, we hit, what was it, the 15th anniversary of the Aleph 1 paper on smashing the stack for fun and profit. Stack for fun and profit. Yeah, so the... Where's the date on it? This result doesn't have the date on it. Yeah, so last year we passed the 20th anniversary of smashing the stack for fun and profit, and it's absolutely crazy to me that so many places like that passed by and nobody talked about it. That's one of the papers that like started so many people going down this route. And I was really disappointed last year when it was I think May of last year, about a year ago, the paper hit the 20-year mark, and that's the kind of thing that I personally would love to have seen like huge celebrations over, and I saw almost nothing. I'm still disappointed about it, but what are you gonna do, right? Okay. We're now sitting here. We appear to be hanging on the multi-array building. Oh man. Bind exploits. Okay. Man, it is crazy to me that there was ever a point where things like bind and Apache and sendmail had exploitable bugs in them that just anybody could find and know about. Um, because that's definitely before I was doing anything even remotely useful as far as security goes. I think the useful things I was doing was I was going to class, but definitely could not drive then. So I was not even close to trying to find something like a bind bug then. Let's see if this will actually get someplace. Come on. I think it's the same place we sat there and hung for a while last time. We got to the point where I think it was this UMath loops, and it sat there and hung forever, and it never got anywhere useful. Come on. So it would have been volume 7. Oh man, it's gotta be weird that FNet is barely a thing anymore. But yeah, so the I assume most people have actually read the ancient Smashing the Stack for Fun and Profit paper, but that was apparently it hit the 20th year at 20th anniversary of the paper last November. And I imagine that that article probably launched more hackers than anything else, except for maybe the movie Hackers or The Matrix or something like that. But uh, come on. It's really unfortunate that building stuff like this takes so long because it's definitely not impressive to watch. Um, it is nice that we have people to chat with instead. So rather than me sitting here and twiddling my thumbs, if I was doing this without the stream, I have plenty of people in the chat to chat with instead. Hmm. Teardrop. I have no idea what those are. Teardrop and milk drop is definitely before my time. On. Getting close. Um, there we go. Okay. This looks like it built properly. I don't see any major errors. It's like this looks built properly. Oh, I'm in the wrong window. Okay, so I want to do source numpy test bin activate. We're gonna leave that up, and I'm gonna cd numpy python setup install. This looks right. And yet, oh so wrong. Okay. So one thing we can do here, I don't actually know what it does. So echo cc, this still works, right? So I want to export c flags is equal to. So I actually don't know what the difference here is, right? Using fno omit frame pointer does something, and it's recommended a lot when it talks about building stuff. Python setup build. But I don't actually know why it does that. However, given that we're talking about option to text stack use after return is failing, I can't imagine that I need to build Python too. Like, there's no way that's true. I mean, it's possible, but I have to imagine that a Python module will build everything it needs. Like, my thought about how this should work is that, yeah, it's entirely possible that I need to actually go and build all this crap myself. Building Python is going to be a huge pain. You know what? Let's get started on that. Since this is running Python, we're also going to get the latest version of Python while we're at it. That's going to be interesting. So Python 2.7.13. Oh, that's interesting. We're actually on the latest version of Python already. cd projects maker Python source. Get to that. Yeah. I would think that they would link in the, like, they would link in all the ASAN stuff into the SO, but I guess they don't. which is unfortunate. RxBF. Yeah, you know, I always forget that apt can do things other than just install binaries, like the, what is it? Sudo apt-get install. No, it's not. I want build dep. Oh, I need to actually set all that up. It's apt, right? Apt. Like the fact that I can just uncomment all these things. Nope. Apt-get update. Depackage. Come on, once this updates. Like, it is crazy to me that I can do build dep and apt knows here are all the things we need if we were to build from source. Let's go install all of them. So now when I go into the Python source code I just downloaded, even though I'm not using apt to do it, I already have all the dependencies I need. It is incredibly useful. I always forget about it. Somebody showed it to me relatively recently that I could do that, and it completely blew my mind that getting dependencies for stuff that you're trying to build from source could be that easy. Okay, we have a .configure. So cc is equal to clang. I'm sorry. I hope this works. cxx is clang plus export c flags dash f sanitize equal to address dash that thing. I also find it interesting, like, thinking about the different build processes, right? So for numpy, they use some of the Python build stuff, the setup tool stuff. But because we're building Python itself, we can't use any of that. So they're using CMake, or no, this is just regular nmake. Make. It's interesting to think about that, right? That all these Python modules can use the Python benefits, like the setup tool stuff, because it's apparently easier to write. But so I'm hoping I don't need the LD flags. Like, I'm really hopeful that the LD flags was just setup tools being dumb, and because this is using make, hopefully it's a lot easier. This is where we go, and now we're watching code compile. It's almost like I'm streaming watching grass grow. I guess the difference is that it's kind of like we spent an hour or two, grooming things and getting to the point where we have some interesting grass to grow, and now we're just watching it grow. Come on. It was kind of funny. I was actually talking about that on the Mastodon today. That, especially the past couple months since I've been doing this streaming, I've been more and more interested in watching other people stream things. Mostly that's because I'm not particularly interested in watching people play games. Like, if I want to play a video game, why don't I play a video game? Oh no, the linker. Okay, so we do. So we also need to do export LD flags is equal to, and hopefully this just works. Sanitize address. But yeah. So ooh, that's definitely fancy. You're reverse engineering a dog shock collar. That is fascinating. Like, are you doing hardware reverse engineering, or are you just looking at the like firmware off of it? I'm a little bit surprised that it actually has enough to be particularly interesting. Oh, that's what I want to do. Python setup install. Oh no, install. Do I need to configure again? I thought I could get away with. Yeah, maybe I do need to configure again. Uh, oh, you're doing SDR stuff? That's something that's always been really interesting to me, and it's something that I've never actually gotten into doing. Like every time I go to a conference, there's always some interesting talks about how somebody bought one of the RTL SDRs and they reversed out exactly what it was doing, and here's how I don't know, we like spying on baby cameras or your garage door clickers and things like that. It's always fascinating stuff, but it's something that I've never had, I guess, the time or what's what I'm looking for, inclination to actually go do. Because even though it's really interesting, it's enough outside of the area of things that I really know. Like, I kind of know how to do some of this stuff. I apparently don't know how to build Python, but we're gonna get there. But that like SDR stuff uses completely different tool sets. It's a very different way of thinking about things, even. So it's something that's interesting to me, but that I've never actually gotten into doing. I hate you so very much, Python. I hope you know that. So the error we have here is that Address Sanitizer has detected that Python leaks memory, so it refuses to build. Hmm. Okay, how do I turn off? Let's see here. I want to turn off the memory leak. How do I turn it off? So the sorry, the problem we're running into here, right, is that the linker won't even return something for Python because it determined statically that you are going to run into memory leaks using Python. But I don't. ASAN turn off leak detector. Okay. Export that. I mean, if we were doing this, like, basically what we're running into there is the ASAN project is primarily designed for developers to use to make their code better. The goal there is to make better programs for developers. So as a developer, if I saw, oh, my program is leaking memory, I probably want to go fix it because I probably care about that and want to get it fixed. However, we're not developers here. Well, I'm not currently a developer. I'm currently somebody who is trying to find and exploit vulnerabilities. And I don't care about memory leaks. I don't care that apparently I can leak tons of memory because those are memory leaks. So they're allocating memory and never freeing it. Especially allocating memory, never freeing it, and then losing pointers to it. Sorry. I don't really care about that. It's interesting. I might need it for an exploit, but I probably don't. All I want it to build. And if it builds... Oh no, there were errors. I don't know if I care. That looked like it worked. Projects, Python source, Python. That looks like it worked. Oh. Ha! See, look at all those memory leaks. None of which I care about. What? Oh, did I not, Python setup install. Come on. Oops, that's not what I want. I want that Python. Why? How do I, I'm sure the problem here is I'm using the wrong... Yep. How does this actually work? See, that's what I thought. So, virtual m specify Python. There. So I need to kill this. rm numpy test. Make sure we get this right. And I want virtual env dash dash Python is equal to Python. No. That slash Python. Numpy test. What? No. Do not like the tilde in your arguments. Slash home. There we go. Export this over. Like that. No module zlib. I don't know how much I care. Do you work? Damn it, you don't work. So, So we don't have zlib. We need to actually build zlib. Otherwise, virtual env doesn't work. Okay. What do I need to build zlib? What on earth is all of this? cd python. So it looks like you should work. Why did you not build? Look in setup py. In detect modules. What does that thing say? In detect underscore modules. So do I just need the zlib.h? You know, that might be true at this point. Yes, we got zlib to build. What? Are you kidding me? Okay. What? Okay, so we're getting close. The executable is not functioning. Thanks. Slash usr local python. You totally work. Why are you lying to me? Import sys.prefix. Why are you lying to me? I hate you so much right now, virtual env. I hope you know that. Python home No module named site. What is site? Okay. Why don't you just build the Python package with the flags you want? Because I think we're going to run into the same problems if I do that. Although I'm getting less and less convinced that's actually true. No, so at least I can still see the chat. There's a little bit of a delay because the way the streaming works, it has to go from my computer, like, it has to re-encode it, send it out. So there can be quite a bit of a delay with the chat before it actually shows up on stream. But I can see it at least still. Hopefully everybody else can too. So, okay. You know what? I am going to do what you said I should do originally. cd python source rm apt-get sudo apt-get source python. I need to add flags here. Where am I adding flags in here? Trying to find the flags in here. Grep Debian rules. Hmm? Like, I would expect it to, like, yes, I would expect it to be here. Okay, I will. So one of the things that I'm not sure if it's going to work or not is I need to set this cxx and copy and paste this and not have to risk a typo. Okay, so cc, we're going to set that to clang, cxx. We're going to set to playing plus C flags. We're going to set to that. Does that need to be in quotes? I don't know if that, I don't think that needs to be in quotes. Doesn't look like that needs to be in quotes, right? We'll find out. So I did that. D package dash build package. Do. You know what? I know I'm gonna have to rebuild this machine, aren't I? This is the point where I have broken everything and everything is bad. Okay, so I don't care about any of those things. So why did that not work? So that looks fine. You to install. All of you install. Go out and be merry. It says installed Python 5. That is most assuredly not what I wanted, though. So it looked like that worked, but it clearly did not work. Why did that clearly not work? Dash I Python 2. I guess it's the one I really want. That is clearly the wrong version of Python. Well, so we have USR mid Python. Great, don't really care about you. So the problem is at this point, I don't want to roll it back. I want to get the version that I tried to build there, and it's not giving me the version that I tried to build there. Come on. Come on. This should be working, and I don't understand why it isn't. USR share Python. Well, actually, I have no idea if this should be working or not. But this is clearly not what I want to see. Oh, this is good. This is definitely good. I love that this is, we've gone around and around in circles, and it still is not doing at all what I want it to do. Let's see here. VirtualVenv is failing. You know what I can do here, and I don't like that I'm doing it this way, but at this point, what's the worst that happens? So we have our numpy build of our ASAN numpy build. We have a build of Python that works. What we don't have is virtualenv working with that. So what? Why did that work? Where does this go? Okay, this is a little bit more like what I expected to see. Sudo python install. That is not what I wanted, was it? Slash USR local lib. Python path, I think, is the right thing. I just don't have it actually doing the thing that I want it to do. But I'm not pointing at the right spot. include Python. No. That is what I want. There we go. It doesn't even give me an error this time. So we still cannot import multi-array. Why, I'm not sure. We used to get an error, right? Like, I'm not crazy here, right? Wait a minute, what? That doesn't sound right at all. Why didn't it install it? Sudo python. Oh, unless... Is that actually the version I'm playing with? No! Man. Everything is broken and awful. How do computers work? I don't understand. Okay, well, I think at this point it's been about 2.5 hours now, of which I think about an hour and a half of this has been trying to get numpy to build with ASAN so that we can actually use it. I think at this point it's a good idea to call it an evening. We can pick it up back up on Wednesday. I'm not sure what the path forward is going to be. I'm going to have to think about that for a couple days. So I was really hoping that we would be able to get ASAN to build cleanly here. Because, for one, it's going to make our crash triaging easier. It's going to let us pinpoint exactly where that heap overwrite is happening. Because if we can pinpoint where that's happening, it should be really easy to go figure out what's causing it, how to control it, things like that. But right now, not so much. We can't get it to build. We've spent at least an hour and a half trying to get numpy to build with ASAN and completely failing at it. And rather than, having people put up with more of this, I think what I'm going to do is I'm just going to we'll call it for now. Sounds like Cassiano is going to take a look at it. I will probably also take a look at it tomorrow, see if I can't get someplace a little bit more useful. Update. Right now I'm going to try and roll back with upgrade. Hopefully that doesn't break everything. But yeah, I'm really disappointed that it wasn't easier to do this, because for one, it's going to make it harder to do triaging if we can't get it working. And it's going to limit what we can do later, because dash fix dash broken install. So sudo apt-get dash fix broken install. Oh. I can't type. But anyway, I think at this point we'll call it an evening for now. We got some progress. We poked at things. We did manage to triage 4 new crashes, which is good. It's definitely not what we were hoping for. So, yeah, it's a little disappointing. I would have liked to get a lot farther. Hopefully getting this to build with ASAN will help us a lot. Because having an ASAN build will also let us catch crashes that we can't right now. One thing that's really interesting is that when we did all this fuzzing, we did it without any sort of ASAN enabled. So it's entirely possible that there are additional crashes and additional bugs. In fact, it's probably fairly likely that there are additional bugs that we hit but didn't catch because ASAN wasn't enabled to actually notify us that, oh, you're reading out of bounds, you're writing out of bounds. Especially the reading out of bounds stuff, we aren't even looking for at all. Because as long as it doesn't cause a seg fault by reading way out of bounds, we wouldn't catch it at all. So, yeah. It's a little disappointing we didn't get farther, but, I mean, we did make some progress. We got to poke at trying to build stuff and failed pretty hard at it. Building Python is tricky. But hopefully for Wednesday we'll have a lot better of a footing to start with. I'm going to try and get all this worked out today or tomorrow and Wednesday morning. I'd like to kick things off Wednesday, hopefully with, and here's exactly how we get this to build. It's super simple. I can't believe I was being a moron last time and couldn't figure it out. But in any case, that's all that I have for tonight. Thanks everybody for tuning in. Thanks for all the help in the chat. I definitely would not have I would have done quite a bit more stumbling around if it wasn't for all of you guys. And the next stream is going to be Wednesday. It's 7 p.m. Eastern, whatever time that converts to in your time zone. I believe that's currently UTC -4, because we're in daylight savings time. And we're going to be doing some more numpy triaging. No, I'm not currently using Vagrant. I've used it before, but mostly in somebody else set it up and I pull it up and down. Mostly what I do is I've just got some VMs that I use. I probably should switch to that, although having a reasonable set of snapshots in a VM kind of gets me most of the way there. So, in any case, thanks everybody for tuning in. If you have any questions or comments, especially if you figure out how to get NumPy to build with ASAN, I would love to hear about that. You should message me on Twitter if you figure it out. Twitter is probably the easiest way to do that, or a comment on this video, or any of the other social media methods. But let me know if you guys find anything, or you have any questions or comments. So, thanks everybody for tuning in, and I will see you in a couple days. Bye, everybody.